Good day. Welcome to another video. We're continuing with functions. Specifically, we're doing inverse functions. So here on our xy plane, we have the graph of f of x, which is equals to 2x. That's the first graph, highlighted in blue. And then we have the graph in white, y is equals to x. And then we have the inverse graph of the graph of f of x, which is equals to a question mark. Okay. So yes, we have our first graph in blue, and then its inverse graph is the green graph. So then how then do we derive the equation of the green graph, which is the inverse of the blue graph, right? About the graph of y is equals to x. Okay, so the two graphs basically they are the same distance from the graph of y is equals to x. Okay, so okay, we know that our graph of f of x is equals to 2x. Okay, and therefore what is the inverse graph? The inverse graph, basically we have to swap the values of y and x in the graph of f of x. Okay, function of f of x. So here we have y is equals to 2x from that one, of which we therefore get that by swapping the values, we're gonna get to x is equals to 2y, and then divide by 2, we therefore get y is equals to basically half x, right? So what therefore becomes our question mark is basically half x. Okay, so that is the equation for the inverse graph. So let me just write it down here. So basically our inverse function is equals to half x. Okay, so yeah, from that we've now derived for the equation for the inverse graph. But now let's now speak about the domain of both graphs. So we have the graph of f of x, and then we have its inverse. Okay, and then we have its inverse. So here, speaking about the domain, we know that the domain for the first graph, the blue graph, is basically goes all the way to the negative x and then all the way to the positive x, right? So domain is basically x is to the element real numbers. But then is it any different with the domain of the graph of the inverse graph? Let's check. So for the inverse graph, basically we also have that it goes all the way to the negative x and then all the way to the positive x, right? So the domain even here is basically x is to the element real numbers, right? And then how about the range? Okay, so the range of the blue graph, basically it goes all the way down and then it goes all the way up, right? So the range here is y is to the element real numbers. But then how about the range for the inverse graph? The range for the inverse graph is basically the same in that it goes all the way down, and then so does it also go all the way up. Okay, so yes, the range is basically y is to the element real numbers, right? Of which now let's compare the x and y values of both graphs. So basically here you have xy values, right, the coordinates. But then for your inverse graph, the two values, they basically swap, right, all the time. Okay, the two values swap all the time. So this is what you end up with. Okay, so now we can move to a parabola. So speaking about a parabola, we know that the most basic function of a parabola is actually f of x is equals to x squared, right? Which I can just sketch down right here on our xy plane. Okay, so this looks something like this. Yeah, of which our f of x we know is equals to x squared, and then what therefore becomes our inverse graph. Okay, Our inverse graph, we know that from this we basically start with y is equals to x squared, right? Of which from that we have to swap values of x and y once again. So we end up with x being equals to y squared, okay? And then now, since we want to make y the circuit root of a formula, we put square root and then square root. Therefore, we end up with y being equals to plus minus square root of what? Square root of x, right? Of which note that this is actually this graph is not a function, right? This graph is not a function, so we cannot express it as in inverse graph of plus minus square root x, but then we can basically express it as in f of x, of which we can choose square root x, or alternatively we can express it by choosing negative square root x. How do we even come to this? I'll just show you just now. So in any case, speaking about this, what we have here, if we were to sketch it on the very same graph, we're gonna have something like this. Okay, yeah, so this is what you can call your y plus minus square root x, okay? Of which what I just sketched now, if you are to check, you will get to notice that this graph doesn't pass the vertical line test. What is the vertical line test? It is basically a line like this, of which we know that when we have x and y, the relationship according to vertical line test is that basically we must not touch the same x value for different y values, right? Of which we know that the relationship for it to become a parabola or a function, not for it to become a parabola, but for it to become a function, we must have 1:1 or many x values is to one y value. But now in this case, you can see that instead of that, we have many y values, of which we have a y value here and a y value here for the same x value. So it is therefore not a function, right? Yeah, but when we have a graph like this is a function, since basically right here and right here we can have the same y value, right? We can have the same y value for different x values. But here, also using the vertical line test, we see that it doesn't touch 1 point, but it touches 2 points. Therefore, the graph is not a function. Okay. But let me sketch with regards to maybe using this right here. Okay. So this is basically when we've chosen f of x, where its domain is x is greater than or included 0, right? So what does that mean? XY. So remember that the original graph basically is something like this, right? And then all the way to the positive. But now since the domain is greater than or included 0, so this is the graph that we get to sketch, right? We leave out the one on the negative x, okay? So yeah. And then what therefore becomes the inverse graph? The inverse graph therefore becomes square root x, right? Of which, let me sketch square root x will be something like this. Okay, so yeah, that is our square root x, of which now, okay, let's begin with f of x, and then we'll have our inverse over there. So let's compare the domain and the range once again. Okay, domain and range once again. So here, the domain of this one, it has already been restricted, right? So it is access to the element real numbers where x is greater than or included 0. And then what is the domain of the other graph is basically the same, x to the element real numbers where x is greater than or included 0, right? And then what about the range? Even here, the range is x is so y is to the element real numbers where y is greater than or included 0. And then here it is y to the element real numbers where y is greater than or included 0, right? But then let's bear in mind that there's also where we could have chose the domain of the graph of f of x to be less than or included 0, of which in that case we would have chosen these values right here. Okay, and upon us choosing those values, the other graphs, it tends to become like this, right? Okay, x, y. So from this, what is it that we're gonna have? We're gonna have f of x. Let's do domain and range. So domain, we're gonna have x is to the element real numbers where x is less than or included 0. And then here, we're basically gonna have x to the element real numbers where x is greater than or included 0 for the inverse, right? And then range, in the range, we're basically gonna have y is to the element real numbers where y is greater than or included 0. But in here, instead of that, we get what? We get the opposite, right, as well. Y is to the element real numbers where y is less than or included 0. Okay, so yeah, in any case, let's look at something that is important. So let's go back to the inverse function. Okay, so for the inverse function, how then can we be sure that maybe given a certain maybe we're given f of x and then given its inverse, how can we be sure that its inverse really is its inverse? Okay, so let's say we are given the graph of f of x as 2x. So how then do we know that f of the inverse half x is actually its inverse graph? So we basically do f of inverse. Okay, so yeah, the y values are derived from the x values are derived from the inverse graph, right? Of which this has to give us x should it happen that this graph right here is the inverse of this graph. Okay, so let's just begin. So if we say f and then inverse of x is equals to, here we're gonna get what? 2, right? And then instead of x we're gonna substitute what? Instead of x, we know that our x will therefore become half x. Okay, given that y is basically half x. Okay, so here we end up with 2 cancelling 2, therefore we end up with x. So we know that therefore this graph is the inverse of the graph of f. I hope that made sense. Thank you for watching the video till the end. Kindly tune in to watch more videos. We will be solving more functions. Thank you.